Hello students, in the 11th standard chemistry, the next lesson we are going to discuss is lesson number 7, that is thermodynamics. Okay, dear students, it's entirely new for you because this lesson you haven't studied yet in your lower classes. Okay, so it's an entire new topic you are going to learn in this 11th standard. What is the topic name? It is thermodynamics. Okay, dear students, first let us analyze the meaning of the term thermodynamics. Okay, so the word thermodynamics is a combination of two words, and those two words are derived from two different Greek words, and those words are thermos and dynamics. Okay, so thermos meaning is heat, whereas the meaning of the word dynamics is flow, which means mainly the thermodynamics covers the area of heat flow, the heat transfer from one particle to another particle, and the reactions which are concerned with the heat transfer. So about everything we will study in this lesson, and so this lesson is called as thermodynamics. Okay, and here the scope of thermodynamics is given. Thermodynamic evaluates the macroscopic properties, and the macroscopic properties are heat and work and their interrelationship. Okay, when heat is supplied to the system, what happened? When heat is removed from the system, what happened? How work is done? Whether work is done by the system or work is done on the system. So about everything in this lesson it will be discussed. So it's given. Thermodynamic evaluates the macroscopic properties such as heat, work and their interrelationships. Okay, and mainly the lessons which we have seen so far, all those lessons whatever we see in chemistry, they will be concerned with the structure, the molecular structure of atoms and or the inner structure of atoms and molecules. But this lesson is entirely different. Here we won't worry about the structure of atoms and molecules. We need not worry about the structure of atoms and molecules. So that is given in the next line. The thermodynamics is independent of atomic and molecular structure. And one more scope of learning thermodynamics is one more scope of thermodynamics is feasibility. The word feasibility means possibility, whether a reaction will takes place under a particular condition. So that possibility or feasibility of a reaction can be studied using the principles of thermodynamics. Okay, so these are the introductory part about thermodynamics. First we have seen the meaning of the term thermodynamics. It is a combination of two Greek words. Those words are thermos and dynamics. Here thermos meaning is heat and dynamics meaning is flow. So mainly this area covers the learning about heat transfer or heat flow, and it evaluates the macroscopic properties such as heat and work and their interrelationship. Then next one, this thermodynamics is independent of atomic and molecular structure. Okay, we need not study about their structure, the arrangement of particles and everything, since it doesn't worry about the inner structure of atoms and molecules. Okay, and finally the feasibility, the possibility of a reaction, whether it will take place under a set of conditions, it is possible or not. So that can be studied using the principles of thermodynamics. Okay students, next we are going to learn about the definitions of some important terms. The first one we are going to learn is what is system and what is called as surrounding. System na enna, surrounding na enna. Okay, system is nothing but whatever thing we have taken under consideration. For example, if you take a cup of water, if you take copper sulfate solution in a test tube, if you take any other solution, ferrous sulfate solution in a test tube, or some other things, whatever case you have taken under investigation, so that is called as system. So scientifically the system can be defined as system is the part of universe. System enga dhaan irukudhu, in the universe la dhaan irukudhu, which is under thermodynamic consideration. நம்ம எதை பத்தி ஸ்டடி பண்ண போறோமோ, எதை பத்தி அனலைஸ் பண்ண போறோமோ, so whatever we have taken into our consideration, that will be considered as a system. Even if you take a cup of tea in a flask, that is also will be considered as a system if it is taken under consideration. புரியுதாமா? இப்போ சிஸ்டம்னா என்னன்னு புரியுதா? நம்ம எதை பத்தி படிக்க போறோமோ, எதை பத்தி நம்ம இன்வெஸ்டிகேட் பண்ண போறோமோ, that is called as system. Okay, so it is a part of the universe which is under thermodynamic consideration. and the system is separated from the rest of the universe by real or imaginary boundaries. இப்போ பாருங்க, ஒரு வாட்டர் பாட்டில் இருக்குது அப்படின்னா, வாட்டர் பாட்டிலுக்கு உள்ள வாட்டர் நம்மளுடைய சிஸ்டம் அப்படின்னா, அது வந்து சரௌண்டிங் வந்து எப்படி செப்பரேட் ஆகிருக்குது? இட் இஸ் செப்பரேட்டட் பை த வால்ஸ் ஆஃப் த வாட்டர் பாட்டில். ஸோ இட் கேன் பி செப்பரேட்டட் ஃப்ரம் த ரெஸ்ட் ஆஃப் த யூனிவர்ஸ் பை எய்தர் ரியல் பவுண்டரி ஆர் இமேஜினரி பவுண்டரி. Okay, so can you able to understand, students, what is system? A system is a part of the universe which is under thermodynamic consideration. Okay, mama. Okay, the next one, surrounding. What is called as surrounding? Surrounding na system thavira micha ellame enadudha surroundings tha. Okay, so that is given in the next point. Everything in the universe that is not the part of the system. Now first ஒரு example சொன்னேன். ஒரு பாட்டில்ல தண்ணி எடுத்தோம் அப்படின்னா தண்ணி வந்து சிஸ்டம், அந்த பாட்டிலுடைய வால் வந்து பவுண்டரி, அப்போ அது போக மிச்சம் எல்லாமே என்னதுதான் சரௌண்டிங்ஸ் தான். ஓகே, ஸோ எவ்ரிதிங் இன் த யூனிவர்ஸ் தட் இஸ் நாட் த பார்ட் ஆஃப் த சிஸ்டம். சிஸ்டத்தில் இல்லாத எல்லாமே என்னதுதான் சரௌண்டிங் தான். ஓகே, the next one, boundary. boundaryனாலே நமக்கு தெரியும் தமிழ் மீனிங் வந்து எல்லை. ஸோ எனிதிங் which separates the system from its surroundings. சிஸ்டத்தையும் சரௌண்டிங்கையும் எது செப்பரேட் பண்ணுதோ that is called this boundary. Okay வாமா? So these are the three important things we have seen from this slide. What are they? The first one is system. What is called as system? It is a part of the universe which is under thermodynamic consideration, and the system can be separated from the rest of the universe by means of a real or imaginary boundary. Then surrounding, we know everything in the universe that is not in the part of the system. Boundary means anything which separates the system from its surroundings. Okay, ma. Next we can see about the types of system. Already we know what is called as a system, and now we are going to discuss the types of system. Generally there are three types of systems. Those are, the first one is open system, second one is closed system, and the third one is isolated system. These three are the types of system. What are they? Open system, closed system, and isolated system. Okay va? Okay ma. So here open system means there is a nice example we can have. When you take hot water in a tumbler, ஒரு டம்ளரில் ஹாட் வாட்டர் எடுக்கிறோம். அப்போ கொஞ்சம் டைம் கழிச்சு என்ன ஆகும் அப்படின்னா, அங்கே உள்ள ஹீட் எனர்ஜி எல்லாமே இட் மஸ்ட் பி எக்ஸ்சேஞ்ச்டு வித் த சரௌண்டிங்ஸ். அதே மாதிரி கொஞ்சம் டைம் கழிச்சு அந்த பவுலில் உள்ள தண்ணியோட அமௌண்ட் என்ன ஆகும்? குறையும். ஏன் குறையுது அப்படின்னா, இட் இஸ் எவாப்ரேட்டட். ஸோ த ரெடக்ஷன் இன் த குவான்டிட்டி ஆஃப் வாட்டர் இஸ் டியூ டு த ப்ராசஸ் கால்ட் எவாப்ரேஷன். ஸோ திஸ் bucket or this tumbler has no lid. நம்ம மூடி வைக்காத காரணத்தினால both the exchange of energy and the matter. Here the matter is the word used to represent the thing we have taken in the tumbler. Okay, so an open system is a one in which the exchange of both energy and matter can take place with the surroundings. Such kind of systems are called as open system. Okay va? Okay ma. So here there is a condition given. In case of open system, dE not equal to 0 and dm not equal to 0. ஏன் பாருங்க, இப்போ dE அப்படிங்கிறது எனர்ஜிமா. இப்போ இனிஷியலாக இந்த எனர்ஜி வந்து ஒரு 90 டிகிரி செல்சியஸ்னு வச்சுக்கோங்க. அப்போ ஃபைனலாக அதுக்கு எக்ஸ்சேஞ்ச் ஆகுது. ஸோ இட் வில் பி அரவுண்ட் ஒரு 30 டிகிரி செல்சியஸ். அப்போ ரெண்டையும் சப்ஸ்ட்ராக்ட் பண்ணி பார்க்கும்போது 90 minus 30 that is equal to 60. So it is not equal to 0. Suppose ரெண்டுமே ஈக்குவல் வைங்க, எனர்ஜி எக்ஸ்சேஞ்ச் ஆகலை, இனிஷியலும் 90 டிகிரி ஃபைனலும் 90 டிகிரி அப்படின்னா கண்டிப்பாக என்ன வரும்? 0 வரல, 0 வரும். பட் இங்கே ரெண்டுமே வேறு வேறு வேல்யூ. இனிஷியலில் த டெம்பரேச்சர் இஸ் ஹை, whereas ஃபைனலில் த டெம்பரேச்சர் இஸ் லோ. ஸோ dE not equal to 0. அதே மாதிரி dm not equal to 0 தான். நம்ம இனிஷியலாக ஒரு 10 ml எடுத்துட்டோம் அப்படின்னா கொஞ்சம் டைம் கழிச்சு அது ஒரு 8 ml மாறுது. இப்போ 10 minus 8 னா 2 ml தான் நமக்கு கிடைக்குது, அப்படி தானே? ஓகே, ஸோ dm is also not equal to 0. So what is open system? A system in which exchange of energy and matter with the surrounding takes place. A nice example I have told you, a few quantity of or a few ml of hot water taken in a glass. Okay, okay. Then the second type of system is closed system. Closed system அப்படின்னா, here only one possibility, that is only energy can be exchanged with the surroundings. we can take the same example. In the last type I told you, take a few ml of hot water in an open tumbler, but now the same quantity of hot water you can take, but it has to be closed with a lid. நீங்க ஒரு மூடி வச்சிட்டீங்க அப்படின்னா water molecules are not allowed to evaporate, or if they evaporate again they will be condensed back to the tumbler itself. But what is possible? The liberation of heat energy from the tumbler is possible. So only heat energy will be exchanged with the surroundings, not the matter which is taken in the tumbler. So such kind of systems are called as closed system. So closed system na enna, only exchange of energy is possible, not the matter. In such case, the condition is dE not equal to 0, but dm equal to 0. In a matter quantity change illa. Initially also 10 ml, finally also 10 ml. There is no change in the quantity of the matter we have taken. So dm na, we have to subtract this one from this, higher value minus lower value. So 10 minus 10 abdina, that will be equal to 0. That is why dm is equal to 0, but in energy that is dE not equal to 0. Okay, mama? Okay. Then the third type of system we are going to see is isolated system. Isolated system is a type of system in which neither energy nor matter is exchanged. அதாவது energy exchange ஆகல, matterம் exchange ஆகல. The same quantity of hot water if you take in a flask, in a thermostat or in a thermos flask, which is not possible. Heat energy also will not be liberated. At the same time, the water molecule you have taken in the flask also will not be allowed to go out. So an isolated system is a one in which neither matter nor energy is exchanged. Matter exchange ஆகாது, energy exchange ஆகாது. Here the conditions are dE is equal to 0 and dm is equal to 0. Okay, mama? Okay, so these are the types of system. What are they? There are three types of systems we have. The first one is open system, second one is closed system, and the third one is isolated system. What is open system? It is a system in which exchange of energy and matter can take place with the surroundings. Then closed system is the one in which only the exchange of energy is possible with the surroundings. Then isolated system is the one that neither the matter nor the energy will be exchanged with the surroundings. Okay, mama? So with these types of system over. Okay, students, the next thing we are going to see is properties of the system. Okay, nama system namakku theriyum. What is called a system? Anything which is taken under investigation is called as system, and there are two properties given about the system. Those properties are, the first one is extensive property, the second one is intensive property. Let us see what is extensive property and what is intensive property. Okay, mama? First let me read the definition. The extensive property is the property of a system that depends on the mass or the size of the system. ஓகேவா? மாஸ் அல்லது சைஸ் ஆஃப் த சிஸ்டத்தை பொறுத்து எந்த ப்ராப்பர்ட்டி எல்லாம் வேரி ஆகுதோ such properties are called as extensive properties. இப்போ பாருங்க, வால்யூம். Let us take 100 ml of water and 200 ml of water. Here we can say this has a low volume whereas this has high volume. So this low and high volume we can fix based on either the mass or size of the system. இது கொஞ்சம் போல இருக்கிறதுனால வால்யூம் கம்மியா இருக்குது, இது நிறைய இருக்கிறதுனால வால்யூம் நிறைய இருக்குது. So this property volume, it depends on the mass or size of the system. So volume is an extensive property. So the examples for extensive property are volume, number of moles, mass, internal energy. Okay, so what is extensive property? The property that depends on the mass or size of the system is called as extensive property. The examples are volume, number of moles, mass, internal energy, and so on. Then intensive property is entirely opposite from extensive property. Here it depends on, but here the property which is independent of the system, independent of the size of the system. சிஸ்டத்துடைய சைஸை பொறுத்தோ அல்லது மாஸை பொறுத்தோ மாறாதது எல்லாமே a intensive property, or in a simple way we can define this intensive property as it will be a constant. The water molecule பாத்தீங்கன்னா அது 1 ml water இருந்தாலும் சரி 1000 ml water இருந்தாலும் சரி 2 liters water இருந்தாலும் சரி its refractive index will be same. Density, even if you take 1 ml water, 10 ml water, 100 ml of water, its density will be same. So here density is independent of either the size of the system or the mass of the system. So such kind of properties which are independent of the size or mass of the system is called as intensive properties. Okay, mama, I think you may have some idea about extensive and intensive properties. What is extensive property? The property that depends on the mass or size of the system is called as extensive property, whereas the property which is independent of the size or mass of the system is called as intensive property. There are a few examples given for intensive property. Those are refractive index, density, boiling point, and molar volume. Okay, mama? Okay. Okay, students, now we can discuss about thermodynamic processes. In this aspect we are going to see a number of processes. Okay, look at the first process. It is reversible process. I think you might have an idea about reversible process, isn't it? Because from your lower classes itself in your curriculum this is surely present. Okay, reversible and irreversible process. Okay, so what is a reversible process? Can we recognize? இப்போ பாருங்க, ஒரு ரப்பர் பேண்ட் இருக்குன்னு வச்சுக்கோங்க. இந்த ரப்பர் பேண்டை பிடிச்சி நம்ம இழுத்துட்டு விட்டோம் அப்படின்னா திரும்ப அது என்ன ஆகுது? அந்த இழுத்து வச்சிருக்கிறது ஃபைனல் ஸ்டேட், ரிலீஸ் பண்ணும்போது இட் இஸ் கம்மிங் டு இட்ஸ் ஒரிஜினல் இனிஷியல் ஸ்டேட். அதை ஞாபகம் வச்சுக்கோங்க. ஸோ அப்போ பாருங்க, ரிவர்சிபிள் ப்ராசஸ் அப்படின்னா the system and the surroundings can be restored to the initial state from the final state without producing any changes in the system and in the surroundings. ஒரு ரியாக்ஷன் நடக்கும்போது ஒரு மாலிகூல் வந்து இனிஷியல் ஸ்டேட்ல இருந்து ஃபைனல் ஸ்டேட்டுக்கு கன்வெர்ட் ஆகுது. திரும்ப அந்த ஃபைனல் ஸ்டேட்ல இருக்கிற மாலிகூல் again it has to be converted into the initial state without producing any changes in the system and in the surroundings. So such kind of processes are called as reversible process. So what is reversible process, ma? The system and the surrounding can be restored to the initial state from the final state without producing any changes. System change irukka koodadhu, surroundings ni change irukka koodadhu. Such kind of processes are called as reversible process. But in the lower classes you might have studied in a different definition. What is that? A reaction in which the product molecules can be converted back into reactant molecule is called as a reversible process. That is also same. Okay, ma'am. The next process we are going to define is irreversible process. The name itself implies that irreversible must be opposite to that of reversible process. Irreversible kandipa idukku opposite ah irukum. The reversible process ku opposite ah irukum. So the irreversible process we can define that the system and the surroundings cannot be restored to the initial state from final state. ஒரு வாட்டி நடந்ததுன்னா நடந்ததுதான். இப்போ ஒரு கிளாஸ் பீஸ் எடுத்துக்கோங்க. முகம் பார்க்குற ஒரு கிளாஸ் பீஸ் எடுத்து தரையில் போட்டு உடைச்சிட்டோம் அப்படின்னா உடைஞ்சது தான். திரும்ப அந்த உடைஞ்ச பீஸ் எதா மாற முடியாது, உடையாத ஃப்ரெஷ்ஷான கண்ணாடியாக மாற முடியாது. ஸோ such kind of processes are called as irreversible process. Final state இருந்து we cannot convert back into initial state. That is irreversible process. It is defined that the system and the surroundings cannot be restored to the initial state from the final state. Okay, mama? Okay. The next process we are going to see is adiabatic process. Adiabatic process is the one which is defined as there should be no exchange of heat between the system and the surroundings. Systemத்துக்கும் surroundingsக்கும் இடையில heat transfer இருக்கவே கூடாது. Such kind of processes are called as adiabatic processes. இப்போ பாருங்க, ஒரு கப் ஆஃப் டீயை நம்ம ஃப்ளாஸ்கில் ஊற்றி வச்சோம் அப்படின்னா ஹீட் வெளியிலேருந்து உள்ளே போகவும் முடியாது, உள்ளே இருக்கிற ஹீட் வெளியில் வரவும் முடியாது. ஸோ when the processes are carried in such a type, there should be no exchange of heat between the system and the surroundings. Such kind of processes are called as adiabatic processes. So since there is no heat is flowing, here Q is equal to 0 and Q is a term used to represent the quantity of heat. Qங்கிறது இதை எதுக்கு யூஸ் பண்றாங்க? To represent the quantity of heat. Okay, so what is adiabatic process? There should be no exchange of heat between the system and the surroundings. For adiabatic process, Q is equal to 0. Okay, students, look at the next process. The next process we are going to see is isothermal process. Okay, mama. Often we will use the word iso. Iso அப்படின்னா same. The meaning of the word iso is same. Thermal means it is mainly used to represent the heat or the temperature. Okay, so isothermal process is a process in which the temperature of the system remains constant. அந்த ரியாக்ஷன் நடந்து முடிக்கிற வரைக்கும் டெம்பரேச்சர் எப்படி இருக்கும், கான்ஸ்டன்டாகவே இருக்கும். இனிஷியல் ஸ்டேட்லையும் சேம் டெம்பரேச்சர், ஃபைனல் ஸ்டேட்லையும் சேம் டெம்பரேச்சர். ஸோ சச் கைண்ட் ஆஃப் ப்ராசஸஸ் ஆர் கால்ட் திஸ் isothermal processes, and here the condition is dt is equal to 0. இப்போ பாருங்க, T1 அதாவது இனிஷியல் டெம்பரேச்சர் ஒரு 50 டிகிரி செல்சியஸாக இருந்தால் ஃபைனல் டெம்பரேச்சர் T2வும் எப்படி தான் இருக்கணும், 50 டிகிரி செல்சியஸ். அப்போ ரெண்டுக்கும் டிஃப்ரென்ஸ் கண்டுபிடிக்கும் போது 50 minus 50 that is equal to 0. So that is why dt, பொதுவாக அந்த d delta அப்படிங்கிற டேர்ம்லாம் they are used to represent the change in the values. dt அப்படின்னா change in temperature, dp அப்படின்னா change in pressure, dv னா change in volume. Okay, so what is isothermal process? That it is a process in which the temperature of the system remains constant. Temperature constant ah vachi nadakra reactions ku பேரு தான் isothermal process. Okay, then next process we are going to discuss is isobaric pressure. Here isobaric pressure means volume of the system will be constant. Okay mama, sorry, not volume, pressure of the system will be constant. Isochoric only volume. Okay ma? Okay, sorry for the inconvenience. Okay ma, so isobaric pressure, so isobaric in the sense it is a process in which the pressure of the system will remains constant. The initial pressure will be equal to that of final pressure, and so we can write the mathematical expression dp that is equal to 0. Initial pressure and final pressure same ah irukradanaala dp is equal to 0. Okay mama. Okay, next process we are going to see is isochoric process. Here volume is a constant. ஓகேவா, இனிஷியலாக என்ன வால்யூம் எடுக்கிறோமோ இந்த ரியாக்ஷன் முடியும் போது ஃபைனலாகவும் the same volume will be there. Such kind of processes are called as isochoric process. So what is isochoric process? Volume of the system remains constant. Okay, so for such reaction dV is equal to 0. Change in volume is equal to 0. Okay, and finally we are going to see an important process that is called as cyclic process. So cyclic process is a process in which a system returns to its original state after completing a series of changes. ஒரு சிஸ்டம் வந்து நிறைய சேஞ்சஸ்க்கு அப்புறமா என்ன ஆகுது, ஃபைனல் ஸ்டேட் போகுது. திரும்ப அந்த ஃபைனல் ஸ்டேட்ல இருந்து அப்படியே எங்கே வருது, இனிஷியல் ஸ்டேட்டுக்கு வருது. ஸோ இட் இஸ் அண்டர்கோயிங் a set of cyclic reactions, and so this process is called as cyclic process. Okay mama, a system returns to its original state after completing a series of changes. So for cyclic process du is equal to 0. Here u is called as internal energy. Internal energy அப்படின்னா அந்த மாலிகூல்ஸ்க்கு உள்ளே இருக்கக்கூடிய எனர்ஜி. dh அப்படின்னா என்தால்பிமா, இந்த டேர்ம் நம்ம கண்டிப்பாக தெரிஞ்சிருக்கணும். ஹைட்னா என்தால்பி, என்தால்பினா ஹீட், அந்த சிஸ்டத்தை இன்வால்வ் ஆகிற ஹீட். டிபினா ப்ரெஷர், டிவினா வால்யூம், டிடினா டெம்பரேச்சர். ஸோ ஆல் தீஸ் திங்ஸ் வில் பி 0 for which process? Cyclic process. Cyclic processனா என்ன? A system returns to its original state after completing a series of changes. For cyclic process du equal to 0, dh equal to 0, dp equal to 0, dv equal to 0, and dt is also equal to 0. Okay mama, what are the processes we have seen? We have seen reversible process, irreversible process, and then adiabatic process, isothermal process, isobaric process, isochoric process, and finally cyclic process. Cyclic process. Okay mama. Okay dear students, the next part, the introductory part is completed. Then we will discuss about the laws of thermodynamics. Thermodynamics has a few laws, about that we have to discuss. In this lesson we will discuss about zeroth law, first law, second law, and third law. So these four are the laws we are going to discuss in this thermodynamics lesson. Okay, first we can discuss about zeroth law of thermodynamics. Okay, this is a picture given to explain the zeroth law. Okay mama. Okay, so first paranga, let me read the law for you. First one, if two systems are separately in thermal equilibrium with a third one. ஓகேவா? இப்போ B and C, A is one system, B is another system, C is another system. இப்போ Bயும் Cயும் தெர்மலி ஈக்லிபிரியம். தெர்மலி ஈக்லிபிரியம் அப்படின்னா அவங்க ரெண்டு டெம்பரேச்சர் எப்படி இருக்கும்? சேமாக இருக்கும். Now when these two are tend to be in equilibrium with a third system, that is A. Now இந்த மூணு பேருக்கும் உள்ள heat exchange நடந்து then these three are tend to be in thermal equilibrium with themselves. Okay, so this is called as zeroth law of thermodynamics. ஓகேவா? ஒரு சிம்பிளஸ்ட் எக்ஸாம்பிள் வந்து தெர்மாமீட்டர் தாமா. இப்போ தெர்மாமீட்டர் எடுத்துட்டிங்க அப்படின்னா நார்மலாக நம்ம ரூமில் வச்சுருக்கும் போது அந்த ரூம் டெம்பரேச்சரும் அதுவும் ஈக்லிபிரியமாக இருக்கும். ரூம் டெம்பரேச்சர் எவ்வளவோ அதே டெம்பரேச்சர் தான் அங்கேயும் மெயின்டைன் ஆகும். பட் இப்போ அங்கே இருக்கிற தெர்மாமீட்டர் அப்படியே கொண்டு போய் ஒரு ஃபீவர் அஃபெக்டான ஒரு ஆள்கிட்ட நம்ம வைக்கும்போது அந்த ஆளுடைய பாடியில் டெம்பரேச்சர் எப்படி இருக்கும்? அப்போ அந்த தெர்மாமீட்டருங்கிறது பின்னு வச்சுக்கோங்க, ரூம்ங்கிறது சின்னு வச்சுக்கோங்க, ஹியூமன்கிறது ஏ. ஆல்ரெடி இந்த ரெண்டு பேரும் தெர்மலி ஈக்லிபிரியமாக இருக்கிறாங்க. இப்போ இந்த ஹியூமனில் கொண்டு தெர்மாமீட்டர் பிளேஸ் பண்ணும்போது ஹியூமன் பாடியில் இருக்கிற டெம்பரேச்சருக்கு தகுந்த மாதிரி யார் அட்ஜஸ்ட் ஆகிறான்? அந்த தெர்மாமீட்டர் வந்து அட்ஜஸ்ட் ஆகுது. ஸோ அதுதான் zeroth law of thermodynamics. If two systems are separately in thermal equilibrium with a third one, then they tend to be in thermal equilibrium with themselves. மூணுமே ஒன்றுக்கு ஒன்று தெர்மலி ஈக்லிபிரியமாக இருக்கும். So thermometers are used by this principle. Okay, it's very shortest one. Only the definition will be asked in 2-mark question. What is called as zeroth law of thermodynamics? Okay, so what is zeroth law? If two systems are separately in thermal equilibrium with a third one, then they tend to be in thermal equilibrium with themselves. Okay, and the application is thermometers are used by this principle. Okay, the next law we are going to discuss is first law. Already we have completed zeroth law and now we are going to discuss about the first law of thermodynamics. This also you have studied in the lower classes itself. It is also called as law of conservation of energy. Okay, energy வந்து என்ன ஆகுது? Conserve ஆகுது. The energy of the system will remains constant. There are so many forms are there to give the first law of thermodynamics. In your book there are 5 definitions given. I have taken only the simplest form of the first law of thermodynamics that we have studied in the lower class. Okay, so the first law of thermodynamics is also called as law of conservation of energy, and this is the mathematical form of first law of thermodynamics. Here delta U அப்படின்னா change in internal energy, that is equal to Q is the heat supplied to the system plus W is the work done on the system. This change in internal energy is equal to heat supplied to the system and the work is done on the system. Okay, mama. So this is the mathematical form of first law of thermodynamics, and this is the statement of first law. So the first law of thermodynamics states that energy can neither be created nor be destroyed, but it can be converted from one form to another. நம்ம எனர்ஜியை உருவாக்கவும் முடியாது, எனர்ஜியை அழிக்கவும் முடியாது, but one form of energy can be converted into another form. Okay, so this is the statement of first law of thermodynamics. What is the statement? Energy can neither be created nor be destroyed, but it can be converted from one form into another form. Okay, and based on this mathematical expression we have 4 cases that we can see now. Okay, the case 1, for a cyclic process அப்படின்னா delta U will be equal to 0, that we have seen in the previous slide. Okay, so delta U 0 இருக்கும்போது Q plus W that is equal to 0, and so we can write Q that is equal to minus W. So we can say in a cyclic process the heat supplied to the system is equal to work done by the system. Q is equal to minus W. So what we can say, in a cyclic process the heat supplied to the system is equal to the work done by the system plus W அப்படின்னா work done on the system, சிஸ்டத்துக்கு மேலே ஒர்க் பண்ணப்படுது, minus W அப்படின்னா work done by the system, சிஸ்டத்தால் ஒர்க் பண்ணப்படுது. ஓகேவா? ஓகே, அடுத்த கேஸ் 2 பாருங்க. ஐசோகோரிக் ப்ராசஸ். ஐசோகோரிக்னா we know volume will be constant, delta V that is equal to 0. Okay, what is the mathematical form we have? Delta U that is equal to Q plus W, and for W work done we can use the term minus P del V. So instead of W, we can use the term minus P del V. அதனால delta U that is equal to Q minus P del V. Here isochoric process. Isochoric na delta V will be equal to 0. So delta U that is equal to Q. QR. ஓகேவா? அப்போ என்ன சொல்றாங்க அப்படின்னா ஒரு ஐசோகோரிக் ப்ராசஸில் the change in internal energy delta U will be equal to Q. Qங்கிறது என்னது? Heat supplied to the system. ஓகேவா? ஓகே. அடுத்து கேஸ் 3 பாருங்க. For adiabatic process. Adiabaticனா என்ன? There should be no flow of heat in and out to the system. Such kind of process is called as adiabatic process. And we know the condition for adiabatic process. Q will be equal to 0. அப்படிதான் adiabatic processல Q ஓட வேல்யூ என்னது? 0. Okay. Then come to the mathematical form. Delta U that is equal to Q plus W. Delta U that is equal to Q plus W. Here the term Q is equal to 0. Up delta U is equal to W. So in an adiabatic process, the change in internal energy is equal to the work done on the system. Okay, the final the case number 4 we have, that is for isobaric process. Isobaric na pressure will be constant. So delta U that is equal to Q minus P del V. So this is the expression showing for isobaric process. Okay, so 4 processes we have taken: for cyclic process, for isochoric process, for adiabatic process, and for isobaric process. Okay, so with this the first law of thermodynamics over. What is first law? It is also called as law of conservation of energy. Its mathematical form is delta U that is equal to Q plus W, and its statement is energy can neither be created nor be destroyed, but it can be converted from one form into another form. And there are 4 cases based on the first law we have seen. Okay students, next we are going to see an important question, that is relation between H and U. Here H is enthalpy and U is internal energy. Okay, enthalpy na heat, internal energy na and the molecule ku evlo energy irukudho, that is called as internal energy. Okay, and this is the expression we have to study. Enthalpy H that is equal to U plus PV, internal energy plus pressure into volume. Okay, so imagine there is a reaction carried out in which in the initial state this expression can be written as H1 that is equal to U1 plus PV1. P a variable portal appadina, it is a constant. Okay, the same equation for final state it will be modified to H2 that is equal to U2 plus PV2. Okay, now the change in enthalpy can be written as final state minus initial state. So H2 minus H1 that is equal to U2 minus U1 plus P is a constant, no? So P into V2 minus V1. Okay, the change in enthalpy can be written as H2 minus H1 that is equal to U2 minus U1 plus P into V2 minus V1. Okay, okay, and for representing the change we will use the symbol delta. Here change in enthalpy, no? So delta H that is equal to delta U plus P del V. We can have this equation one side, and the next thing we can do. Okay, we know first